Have you ever thought about how hard it is to pick up an object? You see, I've been trying to get robots to learn how to do this, and it's actually very, very tricky. You see, for a robot with eyes and a hand, if it has one joint between those two, it can maybe learn to reach to 100 different positions. Add in a second joint, it's 10,000 positions. A third joint, you're up to 1,000,000. There's this combinatorial explosion of all the possible poses and postures that the robot can reach to. Now, when you're looking at a humanoid robot with joints in its eyes, in its neck, and all through its arm and body, there are so many combinations that to go through them all, you could be looking at taking, say, 100 million years. And to be honest, I'm not willing to sit around for that long just so a robot can learn to play pass the parcel. Now, humans, on the other hand, can learn to do this in just 6 months. And the reason that we can do this is because as infants, we are under the influence of a system of constraints that prevent us doing certain actions before others. And they guide our behaviour through a series of stages of different behaviours and different actions. And this is common across all infants. So, for example, if you have a newborn infant, it has very low muscle tone, and it can't really move its arms and its legs against the forces of gravity. That causes it to focus on just moving its eyes. It also has very low resolution in its eyes, which means that those initial movements are very big and very coarse. Over time, the visual resolution improves, and it can make more accurate saccades. After about a month or so, it has enough muscle tone in its neck that it can start to lift its head up and make combined eye and head gaze movements towards objects. Now, because it's already learned good eye control, it can now bootstrap learning head control as well. So it can do both very quickly. After 2 months, it starts to make wild arm gestures, and using the eye and head control that it's already built up, it can learn how those arm movements appear in the space. After 3 months, it's making swiping movements towards objects that it can see. And after 4 months, it finally starts to use visual feedback to guide the hand towards objects. Now, if we can take these stages and build them into a robot, a set of constraints that cause the robot to develop in a similar way to a child, then we can build a robot that learns in a similar way and hopefully be far more efficient. And that's exactly what we've done. So we now have a robot that develops like a child does, through these stages, bound by these constraints. And it learns to reach, not in 100 million years, not even in 6 months, because it is more simple than a human, there are more constraints, and so it actually learns in just 3 hours. And that's something I will wait for.